I'm taking the source material and turning it into a fresh, creator-style YouTube narration with heavy analysis and opinion. Let's dive into what this funding really means beyond the numbers and why it resonates beyond UVic. We start with a big headline: $15.2 million in federal funding for equipment and instruments to boost research across clean energy, climate science, ocean observation, and more. On the surface, that sounds like a standard grant boost, but the deeper story is about how science infrastructure shapes what we can discover and who gets to lead. Personally, I think the real value here isn't just the gear, but the signal it sends about where Canada wants to invest its intellectual capital. What makes this really interesting is how targeted investments in labs and networks ripple across disciplines, from medical imaging to subatomic physics to deep-sea monitoring. In my opinion, this is a case study in strategic funding. You fund the tools, the ideas follow. First major idea: the infrastructure effect. The Center for Advanced Materials and Related Technology gets $2.95 million for instruments spanning sustainable energy, microscopy, quantum computing, and additive manufacturing. What this implies is more than gadgets, it's about enabling cross-pollination between fields. When you equip a lab with state-of-the-art tools, you don't just speed up one project, you raise the ceiling for what early career researchers can imagine. A detail I find fascinating is how equipment acts as a multiplier. Better imaging leads to better materials science, which feeds clean energy tech, which then attracts more talent and more collaboration. What this really suggests is a country-building aspect of science. The infrastructure layer shapes the talent pipeline and the kinds of breakthroughs that become possible. Second idea: proteomics and health under climate pressure. The $2.7 million for UVic Genome BC Proteomics Center funds tools to study health and disease across humans, animals, and plants, plus climate impact. Here's the angle: biology isn't siloed. Climate change changes disease patterns, zoonoses, and crop resilience. Investing in proteomics facilities accelerates our ability to understand how organisms respond at the molecular level to a warming world. My take: this is a proactive bet on resilience, diagnostics, surveillance, and precision biology that scale with environmental stressors. People often underestimate how foundational equipment in biology translates into real-world outcomes like earlier disease detection or crop stabilization. From a broader lens, this ties into a global trend: biology becoming data-driven, instrument-driven, and deeply interlinked with environmental science. Third idea: international collaboration and precision measurements at the frontier. The $4.17 million to fund the Canadian-led first section of a large project at Japan's Super KEKB Particle Collider is a high-profile move. It's not just about Canadian researchers peering into subatomic particles, it's about integrating into a multinational scientific empire where results depend on shared infrastructure. What this really shows is strategic diplomacy via science. From my perspective, the money here signals trust in Canada's ability to contribute to big, collaborative physics projects and to extract value from them, both cognitively and economically. A common misunderstanding is to view big collider work as distant and abstract. In reality, this funding can lead to practical spin-offs, better detectors, data analysis pipelines, and training grounds for Canadian physicists who will later commercialize technologies or inspire new national programs. Fourth idea: ocean observation upgrades and tectonic science. The $1.65 million to upgrade Ocean Networks Canada's Neptune Observatory brings two power and communication nodes online, including the Middle Valley site where three tectonic plates meet. This isn't just cool science, it's critical monitoring of ocean dynamics, seismic activity, and climate signals. In my opinion, this nudges us toward a narrative where the deep ocean becomes a living sensor for climate change. It also underscores the importance of remote, continuous data streams in understanding long-term trends rather than episodic measurements. What people don't realize is how expensive and logistically complex these networks are. Maintenance, data bandwidth, and the need for cross-disciplinary interpretation turn a pretty map of the ocean into a real-time weather system beneath the waves. Fifth idea: broader national impact and capacity building. The package includes almost $3.7 million in new instruments across 3 university partnership initiatives housed at UVic facilities, plus additional funding allocations to other major universities. This isn't a UVic story alone, it's a national strategy to upgrade labs coast to coast. From my perspective, this matters because talent gravitates toward well-equipped institutions, which then attract collaborations, funding, and students globally. It also raises questions. Will these investments create regional hubs of excellence, or will they deepen competition for scarce talent? Either way, the underlying thread is clear: equipment-driven research ecosystems shape who leads, what ideas dominate, and how quickly Canada can respond to global scientific challenges. Deeper insight: the funding frame and political economy. The 2025 budget earmarked $400 million over 7 years for the Canada Foundation for Innovation, aiming to recruit exceptional international researchers. That's a big policy signal. Canada wants to be a competitive hub for global science. Yet the document also mentions targeted reductions in the same review, which hints at trade-offs and budget discipline. What this raises is a deeper question: can you maintain aggressive capacity building while tightening elsewhere? In my opinion, the answer lies in how effectively institutions convert tools into breakthroughs, and how policy aligns with recruitment, immigration, and research excellence, not just dollars on the shelf. Closing reflection. When you look at funding like this, it's tempting to see it as a list of projects. But the real story is about the architecture of knowledge, the tools, the collaborations, and the geographic and disciplinary reach they enable. If you take a step back and think about it, this is how nations accumulate intellectual capital, through sustained investment in equipment, networks, and people who know how to use them. For the audience, a practical takeaway: watch which institutes land these instruments, and how quickly they translate into new labs, partnerships, and discoveries. What will UVic and its peers publish in 5 years that would not have happened otherwise? That's the real metric. Thanks for sticking with me. If you enjoyed this breakdown, drop a comment on which piece of equipment you think will have the biggest ripple effect in the next decade, or tell me which field you'd love to see accelerated by this kind of funding. And if you want more deep dive analyses like this, consider subscribing for the long view on science policy, research ecosystems, and the hidden engines of innovation.